Assalamualaikum and very good evening. My name is Amira Husna binti Rosli. So for today, I would like to present on my part in the assignment 3 entitled Simulation on Power System Protection, where we got the journal based on the performance evaluation of overcurrent protection relay based on relay operation time (ROT). Firstly is the part of the introduction, where a power systems need to be flexible in addition to being able to handle the current load. The fundamental characteristics of a protection system, such as selectivity, stability, speed, and sensitivity, must be achieved via a competent protection strategy. However, the relay that needs to be activated because of the fault occasionally malfunctions, either by operating solely or not at all when necessary. So to isolate the defect quickly and the affected region from the service, a protection mechanism is required. So this enables the major portion of the electrical grid to remain operational. So, the overcurrent protection, which is employed with the overcurrent relay at the measuring instruments to detect the current magnitude that exceeds the specific adjustable current magnitude, will be the only focus of the project. So, a model for overcurrent relays is presented in the studies. So, using PSCAD, an overcurrent relays model is created and simulated in order to evaluate the performance of this model. The instances that were completed include DG installation in a power system, various types of faults, various types of characteristic curves, and various types of curve standards that's to investigate and study the relationship between relay operations time with the condition or event happen.
Hello, I am Saranya Ramani. So I will be presenting about the problem statement. So one of the most crucial and fundamental protection mechanism in a power system is overcurrent protection. However, fault current can cause power system interruptions. Additionally, one of the cause is the incorrect location or incorrect selection of power protection equipment. Therefore, to maintain and improve the performance of the protection system, this project presents a model of overcurrent protection scheme in power system network to investigate the effect of overcurrent relay protection on relay operation time centered on several cases. The model of overcurrent protection system is developed and analyzed by using PSCAD simulation software based on several requirements or conditions such as various types of location, various types and location of fault and relays. Besides that, analysis under the implementation of different curve characteristics and various standards are also performed in this journal. So, what is overcurrent protection? It is a method to protect against damage brought on by an excessive current flow to the machinery or the components of the power system. The protection mechanism detects the fault based on the fact that the fault current is obviously more than the ordinary load current once the issue arises. So there are two types of overcurrent, which are instantaneous current overcurrent and inverse time overcurrent. So principle of a relay operation. So this figure shows the protective scheme logic operation, which start from the input, measurements, determination and output all exists. The input will represent any values that are present in the protective circuit at any given time, such as current, voltage, frequency or other values. The relay measures the readings and decides whether or not the circuit is working within the normal limits. The output is programmed to open or close the contact when at rest and is zero under typical operating condition. However, the relay will impose an operating signal value under controlled circuit, often expressed in terms of DC volt at any interval fault level. To separate the malfunctioning components from the remainder of working power system, these stripping signals are subsequently routed into one or more circuit breakers, causing them to open. So IDMT overcurrent relay, which is inverse definite minimum time relay, is inversely proportional to the fault current, exhibiting an inverse time characteristic. Relay operating time will be shorter if the fault current is higher. Wide range of operation times and fault current can be graded The type of standard used will determine the characteristic of the IDMT over current relay. So the standard may be ANSI, IEE, IEC, or user created. So after that, the overcurrent relay will determine the operation necessary to match the specific characteristic curve. In addition, it's crucial to comprehend IDMT's inverse time and minimal time principle. The current is increased, the time will pass on an inverse manner, meaning that the operating time for the relay will speed up. So when the current is large, the operation of the relay is quicker, and every protective relay has a predetermined time that depends on the time delay setting. So the inverse link proportion between the operating time of the relay and the function of the current has an impact on inverse definite time. Plug setting and time delta setting are two modifications for overcurrent relay. So this figure shows the inverse time characteristic curves. And so mathematical equation, the characteristics of an IDMT overcurrent relay depends on the types of standard selected for the relay operation. So this is the equation this is the mathematical equation for IDMT overcurrent relay. And this table shows the IEC, IEA and IEC constant for standard overcurrent relay. So that's it for my part. Thank you.
I'm Darshna Priya. Today I'm here to present about my part, that is on the result and discussion. Okay, as we know, for the circuit analysis, only certain part from the overall system will be studied in details. So in figure 3 shows the circuit model for analysis designed in PSCAD software, while figure 4 shows the circuit model in single line diagram view. The circuit was used to investigate the performance of overcurrent relay when subjected to faults, characteristic curve standard, and DG installations. The major components and parameters of the model are 3 phase voltage source, 50 Hz, 132 kilowatt phase voltage. So next, the 3 phase fault block to introduce single phase to ground, double phase to ground, and 3 phase to ground faults. So the duration of the simulation time is 10 seconds and the time to apply fault is 1 second. So next, the model in PSCAD. This is to ensure the overcurrent relay operates in a fast, safe, and dependable manner. It is important to choose the overcurrent relays setting carefully, including the time, dial setting, pickup value, and curve characteristics. If not, the relay will not trip properly or will trip when instructed to not trip. Depending on their rated current, the pickup current of the relays varies. The overcurrent relays pickup current setting typically ranges from 50% to 200%. Next is on the protection system evaluation or verification. The project's outcome will be addressed in this section. As was previously indicated, the goal of this study is to examine the effectiveness of a protective system based on the relay time functioning, ROT. The performance of the IDMT overcurrent relay was examined under various circumstances. The effectiveness of the relay and protection system was investigated using a number of cases, including different fault types, different IDMT relay curve characteristics, various IEE C37.112 and IEC 255 curve standards, and the impact of installing distributed generation DG in the power system were recorded. Next, on the various type of fault. One method for examining how well a protective system performs is to look for various types of failures. In this research, several fault kinds and locations were applied to the circuit to examine how well the protection scheme performed dependent on the duration of the relay. The outcomes were documented for the IEC 6255 standard inverse characteristic curve. The majority of nation utility companies adhere to the IEC 60255 standard. As illustrated in figure 4, the fault is present in a number of locations, including the grid, transformation 2, 3, and load 1. Each of these locations has a single phase to ground, double phase to ground, or 3 phase to ground. Comparison between IDMT curve characteristic. In the world, there are 100 different types of protective standards. IEC 60255 and IEC 37.112 are two of them. Relay characteristic curves are governed by IEE C37.112, which is primarily utilized in North America. A well-known standard that is applied in the majority of European nations is IEC 60255. In many aspects, British standards are comparable. The majority of nation standards are based on either the British standard or IEC standard. The protection system for utility companies like Tenaga Nasional Berhad uses the IEC 60255 standard in practice. Next is the relay operation with DG and without DG installation. The percentage difference between the load and generator increases from 15% to 101%. The differences demonstrated that the higher, the greater the percentage difference of ROT, the further the fault position is from the grid. The combination of the current to the fault spot is what caused this condition to arise. When a fault occurs at the grid is close to the fault point, so the contribution from the grid to the fault is higher than when a fault occurs at the load side. When the grid's contribution to the fault point is lower due to the distance from the fault point, which result in a slow operating time. Additionally, when there is a failure at the grid, a larger current of 40.97 kilo ohm ampere is recorded as opposed to 1.039 kilo ampere in a typical current when there is no DG in the network. When DG units were installed, this phenomena also caused the relay to operate more quickly. So that's all from me. Thank you.
So lastly is the part of the conclusion where the software model is tested utilizing BISCAT software, where there are 4 tests have been carried out. Firstly is diverse fault type, then varied IDMT curve characteristics, implementation of various curve standard, and finally is the addition of a single DG to the power system, where each of the EI curve for each of the circumstance, the relay operation time was faster in each case. Relay failure will affect the load's ability to receive power continuously and reduce the protection system dependability, where the coordination and of the suggested overcurrent relay model in the power system protection SIM should be taken into account in order to make the protection system safe, more reliable, and faster operation of the overcurrent relay. So this will be detailed in a future publication.